Here we have two examples where we want to use integration to solve these differential equations and find a general solution. So what we have is we're given an equation that involves the derivative of y. We see dy dx showing up in this equation, and it is our job to find y. So how we find y from dy dx is we take the antiderivative. We have the derivative, and so in order to find y, we are going to integrate both sides of this equation. So I put an integral on the left side and a right side. And on the ends of both integrals, I'll stick a dx, just to keep my notation correct. The integral of dy dx is simply y. What do we take the derivative of in order to get dy dx? We take the derivative of y. To integrate the right-hand side of the equation, we're going to need to use u substitution. I'm going to choose u to be the denominator, because then my du, which would simply be e to the x dx, shows up in the numerator right here. So I then have just the integral of du that showed up in the numerator divided by the u that showed up in the denominator. And the integral of du divided by u is natural log absolute value of u plus c. Last thing I'll do is replace u when I go back into the equation. Instead of the absolute value of u, I'll write the absolute value of 4 plus e to the x plus c. Looking at our next example, we have the same kind of setup. We want to find y, and so to find y from dy dx, we're going to integrate both sides of the equation, and I'm going to stick a dx on the end of my integrals. The left integral is very straightforward. The integral of dy dx is simply y. On the right hand side, I'm again going to use u substitution because I have the 3x on the inside of that cosine. So I'm going to choose u to be 3x, which means that my du is 3 dx. I don't have a 3 in the integral, so 1/3 du is equal to dx. So when we do our substitution, we then have the 1/3 on the outside of the integral, and on the inside we have cosine of u du. The integral of cosine is sine, so we have 1/3 sine u, and we remember our constant of integration plus c, and the only difference is that when I go back in here to put the value of the integral, I will replace u with what it originally was in terms of x, which is 3x. And there we have our general solution. So the big idea here is that if you are starting with dy dx, the way you get to y is you integrate.